CloudWave is an European Union 7th Framework Program-sponsored solution. This video introduces CloudWave's demo scenario for its third and final year. CloudWave applications are running simultaneously in a cloud which is configured with 3 network segments. The CloudMore application is a voice-over Internet Protocol application, providing Internet-based communication services between users. The Telecom Italia application provides security monitoring, waking up when motion is detected and capturing video to disk. When activated, it requires a high quality of service. A number of third-party applications are running on various nodes in the cloud. The demo starts with CloudMore and Telecom Italia application providers wishing to host their services on the cloud. To begin, service-level agreements for these applications are created. An SLA template for the service level, Platinum, Gold or Silver, is selected, and then customized by selecting limiting conditions on quality of service parameters, such as video jitter. CloudWave's adaptation actions will work to preserve SLA conditions, and in the case where not enough physical resources exist on the cloud to preserve all SLAs, CloudWave will prioritize resource allocation based on the service level of the application. Using the analytics engine, the limiting conditions on the quality of service parameters defined by the application owner are translated into measurable infrastructure metrics, which CloudWave sets as trigger conditions. The CloudWave adaptation engine consists of an orchestrating framework of independent sub-engines. It evaluates a weighted input of all sub-engine recommendations and initiates the highest-ranked adaptation action. Once the applications have been deployed, the cloud operator can use CloudWave's dashboard to monitor the performance of all applications to see how close they are to violating an enactment point. The CloudMore application has now been successfully started. End users make and receive video or audio-only calls to one or more users simultaneously. Unfortunately, after some time, another application co-hosted on the same physical server starts to consume a large amount of resources, such as CPU or bandwidth on the VLAN. The noisy neighbor is interfering with the behavior of the CloudMore application, causing it to starve for bandwidth. This results in a high amount of jitter in the streamed video image, which means poor video quality for the end user. The adaptation engine can suggest a wide range of alternatives like migration, scale up, scale out or adaptation. In this case, the adaptation engine determines that a migration action to quieter host with the lowest network traffic is required. After migration, application operator has insight into monitoring information to better understand why the application performance improved. Through the visualization of the timeline of the application deployment, its performance before and after adaptation can be analyzed. Application operator monitors on the dashboard the status of the adaptation actions that were performed and the quality of service metrics for each stack. After adaptation, the CloudMore end user notices that the quality of the video has returned to normal state. The application developer is able to use suite of feedback-driven development tools to improve the application, to better match real-world runtime conditions. As a result of the migration, the CloudMore application has been migrated to a physical host where the Telecom Italia application resides. For now, the security application is not active, and is not consuming resources. When a security camera detects a motion event, the Telecom Italia application becomes active. The application starts capturing video to disk, consuming a large amount of CPU and memory. With the CloudMore and Telecom Italia applications now streaming video on the same physical host, resources are stressed. The security application has preemptively set an enactment point to trigger early, before its video quality degrades. All cloud resources are now being heavily utilized, with no way to either reshuffle application locations through migration, scale up, or scale out resources to the Telecom Italia application. Since the security application is hosted at the highest service level, CloudWave needs to give preservation of its SLA the highest priority. The adaptation engine requests from the CloudMore application to reduce its resource consumption. The CloudMore application reacts by switching off video, and going to audio mode, reducing CPU and memory use. Service for the critical security application remains unaffected, as both applications continue to run.
Created using Powtoon.